Let's think about cars for a moment. The car that you've had in mind was likely painted with your favorite color. The paint is not only there to make your car look pretty, but it has a more important purpose to prevent rusting. When iron and steel are exposed to oxygen and moisture, rusting will occur. Rusting describes the corrosion of iron and steel. The term corrosion is used to describe the breakdown of the metal when exposed to the environment. When we say a metal corrodes, we mean that it has reacted with water and oxygen from the environment to form their respective oxides. We can demonstrate this using a simple experiment. Place an iron nail in four test tubes. Fill one with regular tap water until the nail is submerged. Fill another with regular tap water and add half a spoonful of sodium chloride, a regular table salt. Shake from side to side to ensure that sodium chloride fully dissolves. Fill the third test tube with recently boiled water and add a thin layer of oil. When we boil the water, we removed any dissolved oxygen, and the layer of oil prevents any oxygen from further dissolving. In the last test tube, add a spoonful of calcium chloride. Calcium chloride removes moisture or water. So in the first test tube, the nail is exposed to oxygen and moisture. In the second test tube, the nail is exposed to oxygen, moisture, and salt. So in the third test tube, the nail is only exposed to water. In the fourth test tube, the nail is exposed only to oxygen. Put a cork or a rubber stopper in all four test tubes and let it stand for a couple of days. You will find that the nails in the first and second test tubes have rusted. In particular, the nail in the second test tube have rusted more than the nail in the first test tube, and the rust has likely flaked off. You may see a reddish-brown precipitate at the bottom of these tubes. The nails in the third and fourth test tubes have not rusted. So what has happened here? The iron has undergone an oxidation reaction, forming hydrated iron 3 oxide or rust. Salt and acid act as a catalyst for this reaction, which is why the nail in the second test tube formed more rust than the nail in the first test tube. Rusting can be very costly if we have to constantly replace these items made of iron and steel. Rust can be prevented if we paint the areas exposed to oxygen and moisture. This is done on many bicycles and cars. Another method to prevent rust is by placing a layer of oil or grease. This is done on many bicycle chains. It helps lubricate the moving parts, which reduces friction and slows down the rusting process. Another way to prevent rusting is a sacrificial protection method called galvanizing. Have a look at this reactivity table. Zinc is more reactive than iron when exposed to oxygen and moisture. Zinc will corrode faster than iron. So if you put them together, zinc protects iron but is sacrificing itself, hence the term sacrificial protection. This method is applied to prevent rusting on ships, and the oxidation of zinc can be described using this following equation. So besides preventing rusting, there is another advantage to this galvanizing process. The formed zinc oxide layer can be removed, and the freshly exposed zinc can corrode once again, thereby further protecting the iron or steel hull.
Hi, my name is Lady Angela Joy Morante and I am reporting Unit 3 Quantities of Chemical Reactions. Last week, two people were killed at the rape party that was held at Nathan Phil Square, downtown Toronto. They believe that the two men were high and well before they fell off the ground during the rape party. Based on the autopsy,
Their heart and brain didn't function normally because of the overdose of drugs and alcohol that results to swollen and damage their heart muscle, and brain swelled and flowed because of the drug they called MDMA or ecstasy that is made more combated by the alcohol. And as you can see on the video, they are all having fun, which is the effect of ecstasy, until the two victims didn't know that their heart beats so fast that damage their heart muscles and affects the cycle of the blood through heart, brain, and all over the parts of the body. What is MDMA and how does it affect our body? MDMA is scientifically known as 3,4-methylene dioxy and methamphetamine. MDMA is usually taken in a film form and supposed to be composed of pure chemical. Ecstasy, in the other hand, is the term for MDMA, which has been chemically altered with other additives like amphetamine or caffeine. Pure form of MDMA affects the neurotransmitters in your brain. Neurotransmitters are chemical in your body which relay messages and controlling things such as reflexes, emotions, and memory. Stage 1, 0.05, which is the stage of subclinical and clinical symptoms are behaving nearly normal by ordinary observation. Stage 2, 0.03 to 0.12, is the stage of euphoria. Clinical symptoms are mild euphoria, sociability, and talkativeness. Stage 3, 0.09 to 0.25, which is the stage of excitement. Emotional instability and loss of critical judgment is some of the clinical symptoms. 0.18 to 0.30 is the stage of confusion. Disorientation and mental confusion is some of the clinical symptoms. 0.25 to 0.40 is the stupor. Clinical symptoms are general inertia and approaching loss of motor functions. 0.35 to 0.50 is the stage of coma, which is the complete unconsciousness. And lastly is 0.45 plus.
This is Lady Angela Joy.
Hi, I'm Donalyn Nicolas. I'm reporting Unit 4, Solution and Solubility.
Water. It's life's most basic need. But there's a water crisis in our world right now. Seriously, a crisis. Nearly 1 billion people live without clean drinking water. It's happening all over the world, especially in developing areas of sub-Saharan Africa, Southeast Asia, and Latin America. It's a water crisis because it starts with water. But water affects everything. Education, health, poverty, and especially women and children. Let's look at a family caught in the water crisis. It's likely they live on less than $1 a day. When they're thirsty, they can't just turn on the faucet for a nice cold glass of water. They don't have a faucet. Instead, the women and children go off to collect water. Many walk up to 3 hours a day to the nearest swamp, pond, or river to gather water that's been sitting out in the open, exposed to all kinds of germs. Time spent gathering water is time they can't spend learning to read, write, earn an income, or take care of their family. Some women in sub-Saharan Africa spend more time collecting water than any other activity they do in the day. And the walk isn't just hard, it's dangerous. The women are alone and burdened with 40 pounds of water. Many get hurt. Sometimes they're even attacked. When they make it home, the little water they've collected isn't clean. Some families know their water is contaminated with germs that cause diarrhea, dehydration, even death. But what choice do they have? Kids, especially babies, are affected most by these germs. About every 19 seconds, a mother loses one of her children to a water-related illness. And each day, almost 1 billion people are living this way. Until they get a little help The water crisis is solvable. There are solutions. Some are brand new and innovative, like water filtration systems. Some are age-old, like drilled or hand-dug wells. These solutions bring clean water much closer to the people who need it. A safe water project near a village restores hours each day to a person's life. This time, it's opportunity. It's freedom to go to school and get an education, to work or start a business, to raise a family. Africa alone could save 40 billion hours each year. That's the entire annual workforce of France. Clean water means less disease. That's less money spent on medicine, which means more money for books and school uniforms. And if the water project is built near a school, it can increase attendance, especially among young girls. The water crisis is vast, but we can solve it. Just $20 can provide one person with access to a clean water project in their village. And this will mean more than clean water. Because water changes everything. Join us.
This is Marie reporting about Unit 5 Gases and Atmospheric Chemistry. Summer's not even officially here, but we are already experiencing extreme heat. And now is a prime time where drivers should be worried about their vehicle tires, making a simple drive turn to a bumpy and potentially a dangerous drive. The hotter it gets, the more at risk tires are to fail. Another reason is because of speeding in a very hot day. This may cause the tire to blow out. One of the properties of gas is called Gay-Lussac's law. Can further explain this. This is a relationship between the pressure and the temperature of a gas. The flexing of the tire as it drives down the road will initially raise the temperature of the air in the tire. When this happens, the pressure of the gas inside the tires increases, which expands and causes the tire to expand until it pops from having too much air.